Okay, we will be reviewing Chapter 6 test solutions and answers. Now, for number 1, there was a chart which had polygons, number of sides, number of triangles, and sum of interior angles in a chart form. For triangles, the number of sides is 3, the number of triangles was 1, and the sum of the interior angles was 180. Now, if you draw a triangle, you can see that no diagonals can be drawn. As you may recall, a diagonal is a line that can be drawn from one vertex to a non-adjacent vertex. In other words, a vertex that is not next to the vertex you are looking at. As you can see in the quadrilateral, once you draw the diagonal, 2 triangles are formed. That's why it says 2 right here. The triangle, since there was no diagonals, the number of triangles is 1, and the sum of interior angles is 180. The quadrilateral has 4 sides, 2 triangles are formed, and the sum of the interior angles is 360. Because 2 triangles were formed, this triangle is 180 degrees sum. This one is 180 degrees sum. So 2 times 180 equals 360. Hence, this is why it says 360 here. The pentagon has 5 sides. 3 triangles were formed for a sum of 540. So you have the pentagon, diagonal, diagonal. 3 triangles were formed. 3 times 180 equals 540. For the hexagon, 6 sides, 4 triangles were formed for a sum of 720. So if you have the hexagon, you have diagonal, diagonal, diagonal. 1, 2, 3, 4 triangles. For the heptagon, 7 sides, 5 triangles are formed, 900 degrees, sum of the angles. The dodecagon has 12 sides, 10 triangles are formed for a sum of angles of 1800. If we continue with the same pattern, we can obviously see that the 70gon is going to have 70 sides, 68 triangles. The sum of the angles will be 12,240 degrees. The n-gon is just any polygon. The n describes the variable. In other words, the n-gon can have any number of sides. In algebra, when you want to express algebraically what any means, you use a letter. Here, we chose to use n. So an n-gon has n sides. If you notice, the number of triangles is always 2 less than the number of sides. When there was 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. What is the pattern you see? The number of sides is always subtracted by 2. So 3 minus 2 is 1, 4 minus 2 is 2. So the number of triangles for an n-gon is n minus 2. As you can see, every time the way we got the sum of the angles was by multiplying the number of triangles by 180. So to get the sum of the interior angles for an n-gon, we do n minus 2 times 180.